All right, we are going to reverse a decimal expansion, and this can be a little bit tricky, so stick with me, rewatch this as many times as you need to. So I want to turn this decimal into a fraction. So first I'm going to find, okay, where is it repeating, right? Where do I see the pattern repeating? And it starts repeating right here, 0.59, 0.59. So I'm going to start by calling this is W. I'm just going to give it a name here. And I want to multiply this by 100. And the reason why is I want to move this decimal over to the start of the next repeating. So I'm going to multiply this by 100. And all that means is if I say, okay, 100W, that just means it's going to be 359.5959. And the reason I did that is I want to move the decimal point so that I can have the pattern on top of each other, and you'll see why now. So I'm going to do 100W minus W on the left. And on the right, 100W is 359.595959. And W, make sure you line up your decimal, is 3.595959. Now, because I multiplied by 100, which means I got the pattern to restart, when I subtract these, those just go away. When I subtract that, it goes away. What's 100 minus 1W is 99W. And over here, I can do 359 minus 3 gives me 356. I've gotten rid of the repeating portion because of how I multiplied it. And now I'll divide both sides by 99. And I get W equals 356 over 99. And that is the decimal expansion. I'll prove it to you right here. 356, let's clear all this out. 356 divided by 99, oops, too many nines, 3.5959. Now, why does it have a 6? It's just rounding. All right, so now go ahead and give it a try. If you aren't sure, go back and rewatch it and just try. There's no harm in getting it wrong, and I show my work on the next slide. So press pause and play when you're ready to see the answer. So now when we look at this here, I multiplied by 100 because there were 2 digits of the pattern. I multiplied by 10 because the pattern was 1 digit. And here, I wanted to get to the end of the repeating decimal, so I multiplied by 5. Don't worry about this challenge if it's confusing you. This is where you want to focus. Those are eyeballs. You want to focus on those 2 there. So the lesson in that is to keep an open mind, and I want you to keep that lesson for what we're about to do. Do you think that the decimal expansion is unique for each rational number? Do you think that the decimal expansion is unique, which means that the only number that has a decimal expansion of 0.3333 is 1/3. No other number has it. The only number that has that decimal expansion is that rational number. So now let's think. Let's go back to our question of the day in the previous video. Is there a number between 9.99999 and 1? Now we said that there will always be a number in between unless they're equal, and I'm going to actually prove that they are equal. Okay, so let's prove that 0.99999 repeating is 1. Let's use the decimal expansion that we did before. So let's say W equals 0.9999. Okay, and I want to multiply, the pattern is 1 digit, so I'm going to multiply by 10. So I'm going to multiply 10W, and that's going to move my digit over 1, so that's 9.99999. So if I do 10W minus W, which is equivalent to 9.99999 minus 0.999, what happens? 10 minus 1 is 9W. Those cross off and I get 9. When I divide both sides by 9, I get 1. But W is actually equal to 0.999. What? What's going on? They are actually equal. Let's look at this in a couple different ways. All right, so let's say, and I'm going to just write it out here. So we've got 1 over 9 is equal to, and if you don't believe that, if you're not trusting me anymore, 1 over 9 is 0.111, okay? Let's say I want to multiply both sides by 9, because you can do that. You can multiply both sides as long as you keep it equal. So on this side, 9 times 1 over 9 gives you 1. And over here, you get 0.9999. They're equal again. All right, let's look at this one in here in the middle. Okay, 1/3 is 0.33. 1/3 is 0.33333. 2/3 is 0.66666. Well, let's add those together. What's 1/3 plus 2/3? That's 3/3. And that's 0.99999. Well, 3/3 is 1. We just proved it again. Okay, last one here. 0.333 is equal to 3 over 9. Okay, do you believe me? Let's double check. Now I know you guys aren't really trusting me. 3 over 9. Now that's 1 over 9. Okay, what about 8 over 9? So then it makes sense, right? If it's 3 over 9, 8 over 9, 9 over 9, 1. Your best bet when you start to look at these more, if you try to do 0.399 and all those, is you use this proof here, but 0.9999 is equal to 1. So another way to think about it is from your textbook. You can pause and read it here, or read it in your textbook. And then using that same idea, what would be another decimal expansion for 0.39999? Can you prove it? Pause and see if you want to give it a try. I'll give you the answer here. It's 0.4. Can you prove it? So that concludes section 2.7, real numbers.